Welcome to Prima Power North America. Today we are in our demo center and showroom here in Arlington Heights, Illinois, just outside of Chicago. My name is Paul Croft and I'm the bending product manager here at Prima Power North America. And today I'd like to talk to you about our Servo-Electric EP-Series of press brakes. So right now we're standing in front of our EP-0520. This is our 6-foot, 60-ton machine. Prima Power offers several different sizes in the EP-Series of electric press brakes. We also offer a 110-ton 10-foot machine, a 12-foot machine that's 150 US ton, and a 220-ton 4-meter machine of 13.6 feet. Now, right out of the gate, I want to talk about probably the most unique feature of our Servo-Electric press brake, and that's the Servo-Electric drive system. So we use a belt and pulley drive system that really makes this stand out against a standard hydraulic press brake. So one of the biggest features that servo drive and pulley system allows us is even distribution of our tonnage across the entire bed length. Whether it's a 6-footer machine or the 13.5-foot machine, the idea of that concept is 2 large servo-electric motors and the belts running through a pulley system across the entire length of the machine. What that does is evenly distribute the tonnage across the entire bed and allows us to eliminate any need for crowning in the system. Another important design feature that really makes our Servo-Electric press brake unique, especially when considering it against a hydraulic machine, is that we run a O-frame design. So that O-frame, instead of the C-frame design that you would normally get on a conventional hydraulic press brake, really allows for a much more rigid frame. That rigidity immediately is going to reduce and virtually eliminate any deflection in not only the ram, but the bed with any twisting or yaw when you put the machine under full loaded tonnage. Another benefit that the O-frame construction design allows us is the elimination of that C-frame gives us the entire bed length to work with as far as bending length. On a typical hydraulic press brake, if you buy a 10-foot machine, generally you have those C-frames that are in about a foot on each side. They're also probably about 12 inches deep, so when you get into any longer flanges, you now have basically been reduced to an 8-foot machine. When you buy a 6-foot machine with us, or a 10-foot machine or whatever size, you get the entire bed length to work with because the O-frame design is on the outside of the bed. Going back to the actual crowning system or the lack of crowning system, that belt and pulley concept with the spreading of that tonnage across the entire bed, we don't need to use any CNC or crowning systems on the bottom. We use a standard wheelless style lower bed that has a wedge system that we can drop it on your floor. We can set up those wedges and do a test to make sure everything's level on your floor. Basically set it and forget it. At that point, you have even bending across the entire bed of your machine and you're good to go. Another huge benefit that Servo-Electric press brakes offer over the conventional hydraulic machines are the consistency and positioning accuracy that we can achieve. Conventional hydraulic machines have valves that are continuously opening and closing and dwell points. On an electric machine, you hit the pedal and it drives down. In the end, I think you'll find that the productivity increases and it's a better overall experience for the operator. Another huge benefit of Servo-Electric technology over hydraulic technology is the overall energy efficiency, which turns into overall power usage. We've done some preliminary testing, and on our 110-ton 10-foot press brake, we can save upwards in the neighborhood of $3,000 to $4,000 a year over equally sized conventional hydraulic press brake. So Prima Power EP-Series of press brakes, we offer multiple back gauge configurations from 2-axis to 6-axis. Right here you're looking at a 5-axis configuration, which is probably our most common setup. The 5-axis gives us X-axis, R-axis, our Z1 and Z2, as well as an X1 or a Delta X, which is 4 inches of stroke on one of our back gauges, both positive and negative. That's a real handy feature, obviously, if you need to do any taper type bends, but probably most commonly used nowadays for side gauging. One of the benefits of this machine, because of its accuracy, there's a lot of multiple tool staging setups that customers use, and that additional axis allows for easy side gauging and optimal alignment of that bend sequence. Another feature that we have is a slightly wider fingers than most I've seen. That could come in real handy when you're doing some smaller parts and you need to only use a single configuration or a single back gauge. You've got lots of real estate to be able to position that part for your bend. All Prima Power EP Servo-Electric press brakes come standard with a rear safeguarding. Each machine has a plexiglass sliding door which offers a nice clean look. Lots of light can enter for the operator, but also keep everyone safe. So we'd open up the side gate here, we can take a little bit of a closer look at some of the internal workings of really what makes this machine work. A couple of obvious big things you can see here are these spring packs that we're looking at. These two large spring coil packs allow the machine's natural state to be at top dead center. If, for example, if the power went out or if the motor somehow gave out and the brakes went away, the natural state for this machine is at top dead center. Those springs will actually return the ram to the top. That's one of the reasons that actually makes this machine incredibly efficient. You can think on a hydraulic machine, when you're holding that ram up at top dead center, you've got motors and pumps whirling away and all that pressure and power and electricity being drawn to keep that machine at top dead center. Our machine's natural state is already at top dead center. Another part that you can see inside the housing is our linear encoders. So even though our electrical motor is obviously incredibly accurate, a lot of the positioning accuracy that we count on comes directly from these linear encoders. This is going to ensure that even if we have a little bit of belt stretch over the years, that's not going to affect the positioning or accuracy of the machine. These encoders are going to take care of that for you. Another huge introduction that we've started using with our EP Servo-Electric machines over the last few years is the block laser safety system. I think personally this is the best safety system out there. It's specifically designed for press brakes, and it allows for maximum efficiency and to gain every little bit of productivity out of these types of machines. So the block laser safety system is the safety system that we've chose to put on all of our eP-Series electric press brakes. We're all probably familiar with light curtains. Light curtains have been used for many, many years, not only on press brakes, but on many types of automation and machinery throughout a shop. The reality is a set of light curtains is there for one reason and one reason only, and that's to keep somebody out of an area. I think we can all agree that keeping someone out of a press brake area is a little counterintuitive. So the block laser safety system, or laser safety devices in general, really is the first safety device specifically made for press brakes. So we're using the block system. The block system is basically a laser beam or a large laser block that follows down the top of your tool throughout the bending sequence. The biggest difference or the biggest benefit you're going to see with a block laser safety system versus a light curtain system is the light curtain is generally, a foot and a half away from your bending tools. On a laser system, we're actually covering and creating a safety point in the actual area that you want to be safe, which is the tip of your punch. The main benefit right out of the gate is I can now work much closer to my tooling and much closer to my dies, manipulating my part, and be running the machine in full high speed. On a light curtain based machine, you can't be inside that light curtain while the machine is stroking in high speed. So that feature alone allows for much greater productivity on any part, or specifically smaller parts that are in that kind of 12 to 18 inch range. So all Prima Power Servo-Electric press brakes come standard with 600 millimeter open height. What that equates to is basically about 17.5 inches of daylight once we get the upper and lower clamping in there. So you got 17.5 inches to play with for your lower and upper tools. We do have the option from the factory to go an additional 4 inches to about 21.5 inches between clamps, which allow for even deeper boxes to be produced. So we have a fairly universal approach to our clamping. Most of our machines that we're selling are with either American style hydraulic or Whela New Standard style hydraulic. Either way, we can outfit your machine with either style, whichever style you prefer. The obvious benefits of upper hydraulic clamping are really twofold. One, the self-seating nature of the clamping, and two, just the simplicity of operator setup. With these machine ground tools with the self-seating process, we can simply pop those tools in with a push button, slide them where they need to be, hit one button on our control, and those tools are locked in and seated and ready to bend. No more coming down under tonnage to make sure everything's ready to go. That right there alone can shave minutes and minutes and minutes off of your operator setup. So here I'd like to show you our controller on our eP-Series press brakes. Regardless of size or options, you get the same controller. It's a touchscreen controller that runs our software on top. Generally, there's 3 different ways you're going to program our eP-Series press brakes. We've got kind of 3 ends of the spectrum. The data entry way, or the most standard way, is what you're looking at here on the screen now. This is still probably the most common way that press brakes are programmed in the industry, and a lot of kind of veteran press brake operators and guys that have been doing this for a long time still kind of default to this way. The nice thing that we've done on our control is, even though there's maybe 4 or 5 pieces of data that operator needs to input for that particular bend, angle, back gauge position, the tools that he's going to utilize, all of that information you find on one single screen. So that the programmer, the operator, doesn't have to jump in and out of different pages. So we made it very, very simple for this data entry style of programming. Another style of programming that we've created on our control is the ability to program in 2D directly on the control. So if I open up a new graphical program, we'll load up the screen here. We'll type in some information. So we're going to type in the length of the bend that we're going to create, or the length of the part. We can put in our material thickness right here. We can select our material from our material library. Now, this material library is customizable. You can add any of your own custom materials that you need or you want in here. But for this example, I'll just pick that. We also have our tool library. This is actually a nice way to show our tool library. We have the full Wilson and Whela tool library for either American or Whela new standard style tooling built in directly in here. We can just show the tools that you currently have, or you can have the whole library at your disposal. But we'll select our lower tool, we'll select an upper tool, we'll insert those, and we'll click OK. So now we have our screen where we can actually draw the profile of our part directly on the screen. So if I just draw this profile, I can then, at that point, once I've drawn the profile, go back and highlight the individual links, the individual bends or flanges, and type in the length that I want for that flange. So maybe 1 inch. If I type on the corner, you can see it recognizes that it's an angle. Maybe we'll make that 110 degrees. Click on the next flange, maybe make that 2 inches, and so on. So once I've created the profile that I want for my bend or for my part, I can click into calculate. We get the tools, the side view of the tools and the back gauges and the part. Now, as soon as I hit this optimize button, and that confirm button has ungraded, that took about a half a second, the software has calculated an optimized bend sequence for me, as well as any collision detection for the tools that I've selected. So if I just click simulate through this, you can see the bend sequence that the machine has come up with, and I'm ready to go. At this point, we can simply go right into our run mode, obviously load our tools up that we require for the machine, get our back gauges in position. If I click on the graphic mode, then the operator can actually look at this screen while he's running through the program, so he gets a little visual to see the next step that he's on. We can even go one step further with this and actually get a pseudo 3D view just out of that view as well. So if it's a little bit of a trickier bend sequence, this 3D kind of isometric view, it's a little bit easier for some operators to interpret and gives you a nice view of the part throughout the bend sequence. Along the top here are our standard buttons. It's a very, very simple interface. We've got our edit mode. We've got a couple of run modes: manual, single mode, semi-automatic, fully automatic. We've also got our program list. We'll show you where any of your programs are. There's a couple of different views: list view or actually icon view. And then we've also got our tool library up here. Again, I showed you this when I created the part, but it's got a full library available. All the different Wilson and Whela tools built in the library. If you have any custom tools, they can be imported into the controller very, very easily as well. The third way we can create programs for our eP-Electric servo press brakes, and arguably the most efficient way, is by programming offline. If you create a program offline, the only thing the operator is going to see is a nice pretty picture of that part. If he double clicks on that program, loads the program, he can go right into his automatic run mode, click the start button to get the back gauges in position, and click on the graphics, and he's ready to go. The obvious benefits of this right out of the gate is that the operator is not doing any programming on the machine itself, and he can spend more time creating parts, and he gets a very, very visual interface to actually see what he's bending and how he needs to bend through that sequence. The package that we use for offline software and offline programming is called AutoPOL. We've been using it for well over a decade, and it's a very, very efficient package. Here we're going to show a quick little video of a demonstration of going through programming of a part in the AutoPOL package. AutoPOL is a 3D programming package that can import most, if not all, 3D types of models, whether it's a SolidWorks file or an Inventor file. The process and the benefits of AutoPOL is that we can actually create that program based on the tools that you're actually going to use and actually have out on the floor. Once we've created that program and find that optimized sequence, the flat blank that software develops is going to be exactly created and dedicated to the physical tools that operator is going to use to bend. So that was an overview of the Prima Power eP-Series Servo-Electric press brake. We'd love for you to come down and visit our showroom and take a closer look at the equipment. We'd be happy to sit down with you and talk about any of your bending requirements. Thanks for considering Prima Power for your fabrication needs.